Last time we were talking about pandas, right? And what we need to actually get started with is NumPy, right? So in the very beginning, during the introduction of the course, I was telling you guys that there are these two packages which are very important. The first one is pandas that we have already covered.
Manish, can you zoom in?
Yeah. The other one which we had to look at is NumPy. So that is what we are going to start with today. So this is going to be a single session. It is not as vast as what we have done with pandas. So this is going to get covered in a single session only, which is primarily today. And it has slightly lesser applications when you want to do data analysis, but then it has other applications when you actually do machine learning or advanced machine learning. That is where it is primarily used, and not directly, but then these are actually used uh, somewhat by the libraries that we use. So application of NumPy is not going to be as direct. This is going to be mostly indirect usage, right? But we should definitely learn this and know some of the key features and key commands, right, in there. So let's get started. The package that we are going to look at is called NumPy, and if I break this, it is called numerical. Num stands for numerical, and py stands for Python. So basically, it stands for numerical Python. So I should probably put put it down here that NumPy stands for numerical Python. So what does it mean, right? What you can do is you can define arrays, right? You can define arrays. You can populate arrays using NumPy, and you can manipulate. You can manipulate arrays, and you can also do matrix operation, which is very interesting, which is what we're going to see today itself, matrix operations. So these are some of the important application areas of NumPy, right? So how do we use NumPy? Of course, the way we import pandas, we can import NumPy as well. So it is very simple. Import NumPy. You don't need to worry about whether NumPy is installed in your machine or not. This comes with the basic Python package. So if you have uh, Anaconda 3 installed, then rest assured that NumPy is going to be part of that package. So you don't have to worry about installing it. You can just import it. This is the alias which is primarily used. You can give any alias, right? For simplicity, I'm going to use np, which is what widely used, right? So how to import the library? You can just write import numpy as np. So I just executed this line and this is actually imported. Now, what do we do with numpy, right? So we can define an array, right? An array is what? What is an array? Let's first define what is an array so that we can actually understand what NumPy does and how it does help you, right? So an array is nothing but a set of data items, right, which are placed next to each other in the memory heap, right? So how does it work? Let's say, and this is you can actually try to recall some of the earlier diagrams that we built for memory heap. If this is your RAM, this is your memory, right? Then you will have small blocks, right? Small blocks inside this memory, right? And array is nothing but, this could be an array, right? This could be an array. Now why I'm saying this could be an array, because you'll store different values, right? Maybe you'll store 2, you'll store a character A, you'll store another character Z, you'll store another number 5.2, you will store another number, let's say 7, and you will probably store a true, a boolean value here, right? A T. So what is common in these data values? The only thing which is common is, or what is the similarity, right? Or what is one thing which is common in them, right? The only thing which is common in them is they are placed right next to each other in the memory. That is what it is. Whatever the address of this cell is, this next cell is placed right next to the first one. The next one is placed right next to the previous one, and that is the arrangement of an array. And this is how an array is stored. So when somebody says that I am defining an array, right? The first thing that should come to your mind is, of course, it is going to have more than one values which it is going to store. They do not necessarily need to be of the same data type. So it could be 1, 2, 3, 4, 5, a simple example, or another array could be, all letters A, B, C, D, right? And another example could be a combination of both of these, right? Right? And then you can do whatsoever, right? You can do alphabets, you can do Boolean values, you can do complex numbers, you can do whatsoever, right? You can do floating point numbers and stuff like that. So if these are all arrays, then one thing which is really true is they are all going to get stored in the memory right next to each other. That is the property of the array, right? And this is how it is stored. So how do you define an array,
But
right? Sorry, yeah, say that.
yeah, means I have a question. But as I remember that what we have learned till yet, that array is the same collection of data type. But now here the definition has been changed of the array. So it
Yes.
is only for the Python or the other language as well.
Yeah, so this is the implementation in Python. You can define an array where you can have any type of or any data type stored into these different locations. So you can do that. Ideally, I mean the if you have learned it in any other language, what you see is you know this, right? What you see is this. Either you
Uh,
see this,
right, same data type of
yeah,
collection.
or you see this, right, where you see all the same data types. But in all my
Right.
discussions so far, I've never mentioned that it needs to be of the same data type. In fact, I've taken examples where you can actually take any kind of data types in there.
So that only defined in Python, right?
Yeah, this is only possible here, right?
Okay.
Not in other programming language. So in C, you cannot do this. In C++, you cannot do this. So with the very first example, right? How do you define an array, right? So np is my alias and dot array, right? And then how do you define the array? What we are trying to create is we are trying to create an array. But then if you see this syntax, what are we trying to do here? This is a list.
Yeah.
So we are trying to create an array from a
Right.
from a list, right? This is how you should interpret this. So we are trying to create an array from a list. So if essentially my array, the name of the variable is going to be arr, and if you look at the type of this variable array, then this gives you nd array, right? So let me first execute this, and it is actually giving you a numpy.nd array. So nd means in dimension array. The reason it says in dimension is because in numpy, using numpy, right, you can define any variable, define an array, right, which can be of n dimensions, right? The example that I have taken here is one dimension, right? Why this is one dimension? Because it has just one row and multiple columns, three columns, right? All of these examples here are one dimension array, right? These are all 1D array. I'll show you examples of how you can define arrays with more than one dimensions, right? So this is a 1D array. This is a 1D array, right? All of these are 1D array because it has one row and n number of columns, right? We will see how we can define a multi-dimension array, or 2D array or a 3D array. So simple. To define an array, you can define the array by using the array function np.array, and then specify what all items you want to specify in here. So this was a simple example, simple array, right? How do you print this, right? It is important for us to actually see what is in there, right? So this is an array which has all of these three elements. Okay, now two dimensions, right? two dimensions. I specifically told you that ND signifies n dimension, right? Now, this could be two dimensions or three dimensions. So how do you do that, right? How do you do that? You can define this a little differently, right? If you define these as two different lists separated by comma, then this becomes my first row and this becomes my second row. So instead of 1, 2, 3, 4, so there are two different ways, right? I'll just show you, right? So if you're np dot array and if you're specifying 1, 2, 3, 4, then this is going to create a one dimension array, 1D array, right? And how will the array look like? 1, 2, 3, and 4. If you break this into two dimensions, how can you do that? So 1, 2, and 3, 4. If you do this, then this is going to create a 2D array, right? And how will this be arranged? This is going to get arranged as 1 and 2 in the first row and 3 and 4 in the second row, and this all will be actually enclosed is in another bracket, which means this is a single array. This is not an example of two arrays, right? This is a single array, right? Which has, you can say, two rows and two columns, right? And the way you're defining it, how it is different, right? It is not all enclosed in a single brackets. This is actually enclosed into two distinct opening and curly brackets, big brackets. So when we are defining it this way, then this becomes an example of a 2D array. And if you look at it here, this is exactly what is happening. We have defined 1, 2 here, 3, 4 here, and then all of this goes into another big bracket, right? And when you do this, then this becomes a 2D array. Okay, what is the type? What is the type? That is important. So what we will do is first print this and then also print the type of, right? So again, it says ND array, right? So this is not going to give you a specific dimensions. This is also always going to give you ND array, right? N dimension array. Whether it is a one dimension or two dimension or three dimension, whatsoever, does not really matter. So this is how you define a two dimension array. Now, what we are trying to do here is we're trying to convert a list into an array. And actually, I'm trying to show that to you separately so that you understand what is happening here. But in a sense, if you look at it, this is what is happening here ever since we started this uh, demo, right? This is also a list, and we are actually converting this list into an array by putting this inside the array function. If you want to do that explicitly, you can do that as well, right? So how we can do that? You can first create a list, right? This is a simple list, just two items. Type of A is list, right? And then you can actually use as array function as well to specify this list, and then this new object that you receive becomes an ND array. So the choice is yours. Either you use np.array or you use np.asArray, the result is going to be the same. It is not at all any value addition to use np.asArray because it is doing the same thing. It is definitely doing the same thing. It is not doing anything other than creating an array from an existing list. So the choice is yours. I think you should continue to use the np.array. There is no value addition in using np.asArray. Uh, yeah, if you are creating a list and then converting that into an array using array function, that works as well. So there's no point in additionally using as array. But then that is also a choice available to you. Okay.
So if we have multiple lists, then can we convert it to multi-dimensional array, right?
Yes, you can do that. So what you can do is in that case, you know how to concatenate multiple lists into a single list, right? So first you can do that, and then the concatenated or the joined list is what you can pass into the array function or as array function. Uh, and once you do that, then all the lists become a single array. That is what you wanted, right?
No, no. I just create like we have three lists, and I need to create three row and two columns like
Haha,
this.
haha,
So we just pass the variable with the comma, right?
right.
And then we can create a multi-dimensional array in
You
that.
can create that, right? So you know how to create the multi-dimension array, right? Or two-dimension array. You provide the first list, comma, followed by the second list. And this is what you
Right.
can do. You can specify the list name here, the first list name here. So that will become your first row. You can specify the second list here, and that will become your second row, right? So that's something that you can do. That is
Yeah.
very much possible. And I think you also wanted to have a control on the number of rows and columns, right? So that is what is called a reshaping,
Yeah.
and that is what we are going to see today itself. How can you change the shape of this, right? So from a this is a very small array, right? 2 by 2. But then if this had been a 3 into 3 cross, um 3 cross or four cross four, right? 4 by 4 array. Then how you could convert this into a 2 by 8 array or 8 by 2 array or 1 by 16 or 16 by 1. These are few things that we are going to look at today. So this is very much possible. To answer your question, you can convert this or you can use multiple lists to create an array. That is possible. So these are the ways how you can actually create the uh, arrays from a list. Now you also have the option of specifying the data type, right? If you want to override the data type, then you can do that. The only thing which is happening is one is getting converted into 1.0 and two is getting converted into 2.0. And you can same ways convert from a float to int. That is possible as well. Okay. Uh, so this is pretty much how you define arrays. Now moving on, right? Let's look at few more things that you can do with NP, right? So what are we trying to do here? This is again not doing anything new. We are first creating a list, then importing NumPy as NP, and then we are creating an array from the my list. So one different thing that we are trying to do here is instead of specifying the list here, we are specifying the variable name for the list, right? And then we are trying to print the type of the array, and I think this is not needed. So yeah, we're just printing the type of the array, which is ND array, and then we are printing the array. So you can specify the variable name as well, and that ways you can actually specify multiple variables as well. If you want, you can specify multiple variables. So let's say you had another variable, you can specify variable 2, but then the thing is that you'll need to enclose this inside a list. So you can do this way. Okay, so I'm just leaving it out so that it does not break. And what are we trying to do here, right? So this is going to give you more details about the array that we are trying to create, right? So what is the array that we are trying to create, right? We are trying to create first row here, second row here, and third row here. So this is going to create a 3 by 3 array or 3 by 3 matrix. Now there are a few, and then we are just creating this array using this list, right? So what are the things that you can know about the matrix, right? This is a variable, right? mat. So what we can do, we can actually print the number of dimensions. So it will tell you what is the dimension. We can print the size, and we can print the shape, and we can print the data type, right? So how these work? Dimension of this array, like we know, is 2 dimension, right? Because it has rows, more than one and it has columns more than one, right? It is more than one rows and it has more than one columns. So it has three rows, one, two, three, and it has three columns. First column, second column, and third column. So this is what gets printed when you do mat.ndim, right? Number of dimensions. So it is showing two. What does the size show, right? So the size is going to give you the number of elements of the array. So the size is going to be 9 in this case because it has 9 elements. And what is the shape? The shape is going to give you, and this is true for pandas as well, right? So shape is going to give you how many rows and how many columns, right? So how many rows and how many columns? Three rows and three columns. And what is the data type? This is going to be simple. Since this has all the same data types, then it is going to give you the data type simply. So int 32 in this case. So let me just execute this. It is all anyways already executed, but then this is going to give you additional information, right? Using ndim for number of dimensions, size for the number of elements, shape for the number of rows and columns, and data type for the data type itself.
One question.
Yeah.
If we have like here we all have the integer type one, what happen if we have like ABC or float data type order, then what will the data type
So,
between?
yeah, so in that case, Python has a generic data type, and that is called object. It is going to actually give you a data type which is called object, which is a generic way of storing anything. So inside an object data type, you can store anything. You can either store an integer or you can store a string, you can store a float number, boolean number, complex number, date. You can store anything. So if you have a mixed set of data elements within an object or within a variable, then this is going to be of data type object, and the name is object. Simple. So that is what it does. Yeah. So moving on, right? This is a slight variation, right? What we are trying to do now, we are taking two tuples, right? See what is happening here. We are taking two tuples as the constituent elements or constituent rows. So the first tuple is, instead of a list, we are taking a list of tuples. So the outer big bracket suggests that this is a list, and this list consists of two tuples, right? Because the inner list is actually not a list, it's a tuple, right? So inner collection is a tuple. So 1.5, 2, and 3 becomes the first row, and 4, 5, 6 becomes the second row. And this is again going to be the same as an ND array or a two-dimension array. So when I execute this, it is going to give you the same values, but then in two rows and three columns. Now, what does it mean? It means that you can create an array from a list. It also means that you can create an array from a tuple. The choice is yours. Whatever collection you have, you can always convert that into a list.
But why we are getting 2.3.4 point, like we have only 1.5 and rest are the number 2, 3, and 4, 5, 6.
So what? Why are you getting what?
Why we are getting in output like 2.3.4.5 points and
Right. So
uh,
Python in this case would not want to lose the precision of 1.5, right? So what it does is the way it stores these values is it will all need to be in the same data type. This is what it prefers. And if it is not, then it will try to pick a data type so that we if we add more information to some of these values, the value does not change itself, and from the rest of it we are not losing any valuable information. So if we convert all of this into int, then this 1.5 will need to be converted into 1, and then we lose zero point 0.5. So the easier option here is to convert everything to a float, and 2 will appear as 2.0, 3 will appear as 3.0. Python does not print decimal value 0 if that is the only value. So that is why it is getting printed as 2 dot. But the reason of converting them into float is because in that case you do not lose out this value dot 5.
but if we are passing the string value over there, then it will not convert it into the float, right?
Yeah, so in that case, it is not going to change anything. In that case, it is going to convert everything into a string. So in that case, 2 will become a string 2, 3 will become string 3, 1.5 will become string 1.5. So it all depends on what actually you're trying to do. So uh, in Gajendra, in this case, right, what we're trying to show is these are all the possibilities. But since NumPy suggests that you will create, you're working with numbers. Primarily, when you create an array in NumPy, trust me, in most of the cases, you will be only dealing with numbers, either integer number or float number or a mix of both. I mean, it's definitely theoretical concept, and you need to know that you can possibly use uh, all the other data types as well, but then that is not widely or commonly used. I hope you understand that.
Yeah, got it.
So most of the times you'll be dealing with numbers only, and that is what it is primarily good at. And some of the applications that we are going to do exactly at the end of the session is what will really amaze you as to how quickly and beautifully you can do so many things, which will otherwise require you to write multiple for loops to do this. So a range and lens space, right? These are two functions that we are going to look at, right? And we have already seen range, right? Range we have already seen. So what does range do? It generates a range of numbers, right? We already looked at it, right? So let's quickly recap and then we can probably use a range then, right? So what does range do? So when you use range 1 to 10 and you provide a step size of 2, then it gives you numbers 1, 3, 5, 7, and 9. You can also specify range -5 to 5 and then step size of 3. In this case, it will give you -5, -2, -1, 0, 1, and 4, right? This is how range works. Now, how does a range work, right? This is a slight variation of a range, right? What is possible here is if you specify a range, then you can also put in the step size, which is in decimals. So in range, you can only specify a integer value as a step size. But if you want to specify this as 2.5, then you will need to use a range function. That is the only difference. If you want to specify instead of 3, 3.25, then you'll need to use a range function. That is the only difference. So if you want your values to increment via a floating point number, you can use range, a range. So what is happening here? See, I'm look at trying to do a range, right? And I'm trying to do a range from 5 to 16, and my increment value is 2.5. So let me make it a little simple. How we can make it a little simple is 1 to 10, and let's make it 2.5. See what is happening? 1 is printed, then the next value is incremented by 2.5, so 3.5 is getting printed. Now you add 2.5 to 3.5, you'll get 6. Then you add 2.5 to 6 and you get 8.5. Now you add 2.5 to 8.5 and you'll get 11, but then 11 is outside of this range. So the only values that you're getting is from 1 to 8.5. So this is the only difference, nothing else, right? So you can use it for howsoever you like, right? So this is an invalid constitution actually. You are starting from 50 and you want to go till -1, but your step size is 5. So you're moving in the positive direction. That way it is giving you a blank uh, list. If you put the step size as, let's say, 5.75 in the negative direction, then you are getting this value, right? So 50 minus 5.75 is 44.25, minus 7.5 is 38.5, and likewise. So this is going to give you the same values, but then the step size is different here. A step size is a decimal floating number. So this is another example. You can just run this and see it for yourself. What we need to look at now is linspace. So what does linspace do? Now it solves a lot of problems of yours, right? Look at the parameters. So looks like the parameters are the same, right? We have three parameters. So what does linspace do is it actually generates these many numbers. It will generate 50 different numbers, right? Between what? Between 1 and 5. That is how it is. And how this is going to do it? It is going to actually, if this is the number line, if this is the number line, right? And this is my 1, and this is my, what was the other number? 5, right? This is my 5. So this is my, let's say, yeah. So 1, 3, 2, and 4. If I ask you to divide this number line into 50 equal size, then what will you do? So this is my first, second, third, fourth, right? I will need to divide this equal into 12.5. This will need to be divided into 12.5. This will need to be divided into 12.5 and 12.5, right? Different equal size elements. And whatever the element comes out to be, that will be my increment size. So what it means is if you look at these values, right? If you look at these values, the first value will be 1 and the last value will be 5, right? So 5 minus 1 is 4, and you have to create a step size where if you increment the step size 50 times, you reach 5, and that is what it is trying to do. So it is creating a step size of 0.08. If you look at it, it is creating a step size of 0.08, right? Let's do this mathematics and you will actually understand this better. So I need to start from 1, reach till 5, but I have to do this in 50 increments. So how do I do that? If I write 5 minus 1, which is 4, divided by 50, I will get 0.08. And this is what it is doing. The first value is 1, then it is incrementing it by 0.08, then again incrementing it by 0.08, right? 16, again incrementing by 0.08, so 24, and that ways it is printing you all the values from 1 to 5 which have a step size of 0.08. The good thing here is that you do not need to specify the step size, right? I'll show you quickly. You can do this using a you can do this using this function as well, a range. But then the problem is here you'll need to specify the step size, right? Almost similar, right? 1.08, 1.16, 1.24, almost similar. The problem is you'll need to know the step size here. But what is beautiful in case of linspace is you do not need to calculate the intermediary step size. You just tell Python how many numbers you want between 1 to 5, and all of these numbers will be equidistant from each other. Let's do something more and find out how it does when you do 10 numbers. So between 1 and 5, it is giving you 10 numbers, right? Uh, what if I want to have 100 numbers? So see, in this case, it is actually incrementing everything by 0.04, right? So simple. If you need to actually create such arrays, then you can simply use either a range or linspace. The difference between a range and linspace is in a range you'll need to specify the step size. In linspace you do not need to specify the step size. You only specify the number of elements that you want, and it will generate all of these numbers for you.
Can we control the decimal values as well?
Yes,
Like,
you can do that, but then why do you want to control that? There are functions where you can actually trim these to 2 decimals or 3 decimals, 4 decimals. But ideally, it is not recommended to trim them. If that is only recommended if you want to show less decimals. But for calculation's sake, you should always use all the precision of a floating point number. That is what is recommended. So you should store all of these precision numbers, right? All the numbers after decimal. But if you want to show only two decimals, you should format your output so that you can just show two decimals. But you should not lose any information from these uh, numbers. That's what the point is. Make sense? Okay. All right. So linspace and a range are the two things that we learned today, and these are really powerful, right? A simple statement, and this gives you so many numbers which are equally separated from each other, right? I'm just leaving it here so that when you look at it, you actually know what is happening here. 4 by 50, why 4 by 50? Let me write this as 5 minus 1. So it will be much easier for you to actually understand, right? So instead of, yeah, I'm just leaving it like this. So now there are a few commands that lets you create these matrices or multi-dimension arrays. Multi-dimension arrays or two-dimension arrays is what we call as matrix, right? So it lets you create these arrays very quickly, right? So let's say you want to create an array which should have only zeros in them. So you can just write np dot zeros, and then how many zeros you want? 5. Okay. So here you have 5 zeros. This is a matrix which gets created, or this is an array which gets created quickly. Okay. How many zeros you want? 3 cross 5. So okay, it can give you 3 cross 4 as well. If you want 5 cross 2, it will give you 5 cross 2, so 5 number of rows and 2 number of columns. If you want 3 cross 4, it will give you 3 cross 4 as well, 3 rows and 4 columns. So it quickly gives you all the zeros in the matrix. So you do not need to specify them separately. Like you do not need to create these lists or specify them as list. You can just write np dot zeros. The same ways you have functions to generate arrays with all ones in them, right? So np dot ones, right? Uh, the function is exactly the same. You can just specify the number of rows and columns, and this is going to give you actually all of those size of arrays, right? But with only ones in them, right? Just one. What are the applications of these? It definitely has application in machine learning, and it definitely has applications when you do some specific data uh, processing, but not very widely used. But you just need to know. These are anyways very simple commands to know. For zero, you need to use zeros. For one, you need to use ones, right? So ones for one and zeros for zero. That is what you can do, and that is very simple. Now comes the fun part, right? What all you can do with these arrays. Let's say if you want to actually add a specific number to all of these, right? So, and that must be a question for you, that must be popping in your head as well, right? So you have np dot zeros and np dot ones. So do we have np dot twos, np dot threes, and np dot fours? So the answer is no, you do not have this, but you can actually create one, right? So how can you do that? I will actually prefer writing it this way. Yeah. So when you do this, what you're doing is you are first creating a 3 by 5 array of all ones, and then you are adding 1 to them. Now when you do that, then what you get is np.twos, right? Similar to np.twos. It is not a function which is available, but then you can do that. If you add 2, then you get something like np.threes. You also
So
have an,
basically, all mathematical functions we can perform.
sorry.
So basically, all mathematical operations we can perform.
Yes, you can perform all the mathematical operations, and we are going to see that very soon today. You can do all the mathematical operations. What it is going to do is whatever operation you have specified here, this is going to be applied on all the individual elements of the matrix, all of these, and that is very powerful. The other function to look at here is, and some of these functions are somewhat repetitive, right? It is the same as np dot zeros, right? If you look at it, it gives you an empty array, but then it is the same as np dot zeros, right? Nothing different. So the choice is yours. For zeros, you can use np dot. Why is it giving you 3 now? It should not be the case. Wait. No, this isn't not. This is not correct. No, there's something wrong in here. There's something wrong in here. There's something wrong in here. It should be all zeros. I'll need to check why. When I ran it earlier today, it was fine, and it is not working fine right now. No, there's something wrong in here. I'll need to troubleshoot and find out. But then np dot empty is the same as np dot zeros. It should either of these should can be used. So let me just look at it and I'll let you guys know what is happening here later on. For now, what we can look at is some of the other functions, right? So np.I is another function, eye, right? What it does is it populates a matrix which is of same number of rows and columns, and that is why you need to specify a single number. So when you specify 2, this is going to give you a two-dimension array, two-dimensional array where the number of rows and number of columns are going to be 2 and 2. And the dot I function is actually going to populate, if you look at it, from the left corner to the right corner, it is going to populate all the ones. So this is np.I2. When you print np.I3, then this is going to give you 3 by 3 array, but all my diagonal, the left to the right diagonal, right, is going to be the top left to the bottom right diagonal is going to be all ones. Now there are specific areas where people want to build such kind of metrics, and you can actually do that very simply in Python, right? If you do 5, then it is going to give you 5 by 5 array, and actually the diagonal is still going to be all ones. So this is the I function. Okay, so moving on. Now this is going to be interesting, and this is something that I was referring to earlier as well. So
Manish,
yeah,
I just tried the empty one, so I also getting the value instead of the blank or
uh,
zero.
you used what?
The
Empty,
empty one.
empty. What
Yeah.
what what is the value you're getting?
So I'm getting the values in the decimals.
But then what is the value you're getting? Are you getting zero dot or three dot?
No, it's 9.302.40 and something like this.
Huh, so
So scientific value we are getting.
something weird happening here. I'll need to check. I'll need to check. Maybe it is getting confused with another variable that I may have used with the same name.
But
But
I just open a new workbook and just try to import the numpy and then create a
so what are the values that
array.
you're getting there?
Just making you. These are the value I'm getting.
Okay. Okay. All right. So let's pause on this. I'll check it and then I'll let you guys know what is happening here. But then this is definitely not correct. Either way, it should all give you zeros. So, okay, np.I is done. Let's look at some of the,
Can you repeat NP to boy? Just missed that.
sorry,
Can you please repeat the NP? I.
dot I. Okay. So np.I, what it does is it actually creates an array of same number of rows and columns as the number specified in the parameter. So if you specify 5, then this is going to give you a 5 by 5 array, right? 5 number of rows, 5 number of columns. And dot I function, what it does, it populates 1 in the diagonal, top left to bottom right. This is what it does. Simply, nothing else. And there are specific application areas where we would want to build such kind of arrays, and this is where you use the I function. Does not is not very widely used, but this is what it does. It is going to populate all ones in the diagonal. So if you specify 4, this is going to give you 4 by 4 array, but then the top left to bottom right array is diagonal is going to be all ones here.
So where we can use these kind of the functions,
You can do what?
where we are using these kind of the function like I,
That is what I'm
NP.
saying. That is what I'm saying. I mean, this specific function does not necessarily have any, common use case. These are very specific use cases, in machine learning, and that too not something that you need to use directly. These are primarily already being used in some of the libraries that you use, right? So these are getting used indirectly in a sense, not something that you will need to ever build uh, unless you are looking at specific use cases. So, to answer your question, Gajendra, I mean, the use cases are very similar, sorry, limited, right? These are very specific use cases, not very common use cases. So, so I don't have an example that I can give you where you can actually use it, right? Yeah. You just need to know this. I mean, chances are that you will probably never be required to use np dot ones or np dot zeros or np dot I for that matter. You may still be required to use np dot a range, np dot linspace, but not these ones. It's just that you should know what are the other functions which are available here. These are definitely not the most common ones. The npi is entry, empty, ones, zeros. These are not the ones which are very widely used. Now, this is something which is a good utility function, right? Something that you should know and maybe required to use as well, right? So np.arange 16 gives you all the numbers between 1 to 15, right? But there's a catch. If you let me put it here, and let me remove this. So when you print this, right, what does np.range do? It will give you all the numbers starting from 0 to this, right? What I am trying to do is reshape, and since these are 16 numbers, I can do a 4 by 4. So what it is doing, it is actually reshaping that array into 4 by 4. I can also do a 8 by 2, so 8 rows and 2 columns, or I can do 2 by 8, right? So the choice is yours. If you really need to reshape the array, then you can actually use reshape. And now this has a great practical application. If you need to resize the array, right, then you can actually do that. And what is the practical application for this, right? Let's say you have data available in a CSV file, which is arranged in some number of rows and columns, and you really need to actually transform them, then that's the way to do it quickly. You can just reshape it. How the reshape is working, it is actually following the same order, right? If you reshape it to, let's say, 4 by 4, then it is in the first row putting the first 4 values, then starting from the fifth value and then putting the next 4 values, and it is doing the same till it is reaching the end of the list or end of the array. But if you specify something like this, then this is definitely going to be invalid, because 4 cross 5 would mean you need 20 elements and you only have 16 elements. So this is not going to be a possibility. You cannot reshape a 16 element array into 4 by 5. You know, the multiplication of these two will need to result into a 16. So 4 cross 5 is 20, and that is why you have a value error, a syntax error. So let me just keep it simple. 4 by 4. The other few functions here, which are actually not very widely used, but then you should definitely know, is a diag function, diagonal function, right? What it is giving you is again these diagonal values 0, 5, 10, and 15. Somewhat similar to what the I function was doing, right? I was actually populating all of the diagonal values to 1. Now, the diag function, diagonal function, is actually giving you all the diagonal values 0, 5, 10, and 15. There are other applications of diagonal function as well. There is another parameter that you can specify. K is equal to 2. K is equal to 2. So what is k is equal to 2 going to do, right? I'll probably take a whiteboard to demonstrate this. So, okay. So what is k is equal to k 2 going to do is, let's say you have a example of a matrix which is 4 by 4. So this is a matrix. This is my 4 by 4 matrix. So when you were doing when you're calling the diagonal function, then it was giving you these elements, right? 0, 5, 10 is equal to 15. Although we did not specify, but here the k value was by default taken as 1, which means the extreme center, the absolute center. But when you specify diagonal k is equal to 2, which means the next diagonal on the right side. So in that case, it is going to give you this one, this value. So this is k is equal to 1. This is k is equal to 2. If you look at this one, this is going to be k is equal to minus 1. So what it will give you is this one, 4, 9, and 14. And let's quickly look at if that is happening or not.
I think by default k equal to 0 because as I can see in the output, so k equal to 2 is giving 2 or 7.
Let's look at it. Yeah, you're correct. You're correct. You are correct. K is equal to, this is 0. This is k is equal to 0. This is k is equal to 1. And this is k is equal to minus 1. Yeah, so this one is correct. Um, and yes, k, the default value is 0, which means the absolute diagonal. So since we did not specify anything, this is going to give you 0, 5, 10, and 15. But when we do k is equal to, let's start with 1. So this is going to give you the next diagonal, 1, 6, and 11. But when you do k is equal to minus 1, then this is going to give you the diagonal on the
4,
left
9,
side,
14.
4, 9, and 14. So you understood, right? So this is how it is working. Okay. So let's look at another function. What is diagflat, diagonal flat, right? So it is the opposite of the diagonal function. So a diagonal function was, what was it doing? It was extracting values, extracting the diagonal values from a an array, right? Or a two-dimension array, or a multi-dimension array where the number of rows and columns were the same. Now in this case, diagonal flat, what it is doing is actually it is populating that value. So what is it doing? See, there are two values, four values that we specified, right? And all of these values have become the diagonal values of this array. So it is the opposite. Instead of picking these values from the diagonal positions, it is actually inserting these values there. And since we have,
So
yeah,
yeah, like we are providing the two list over there. If we are providing only single list, then it will work over.
It will
in that
work,
one.
of course work. But then in that case, what do you think the size of the array is going to be?
Like if you provide 1, 2, 3, 4 in a single list.
No. So if you are providing two values, then what will be the size of the array? That is what the question is. It is going to be, it needs to just place two values, right? The first value and then the second value. So what is the size of the array? 2 by 2.
Or 2 by 2.
If you specify four values, then what should be the size of the array?
That's what I'm saying, that if like if you're providing the single list 1, 2, 3, 4,
Haha. It will be the same.
so
Yeah, it will be the same. There is absolutely going to be no issue. The outcome is going to be the same. You can, that was an example which tells you, and that is something which is in reference to your very first question. Can I actually club two lists? So you can club two lists. You can either use one list. The choice is yours. You can do both.
right, right.
But then the what will be the number of rows and columns? It will totally depend on what is the size of the array here, right? So if it is 1, 2, 3, 4, then of course it will need to have four rows and four columns, and that is how it will be. The other option here is the k value, right, which is specified here. So see, it is being specified as 1. So what it is doing is, it is actually, instead of populating the values here, it is moving to the next diagonal on the right side, 1, 2. Let's say if we specify 1, 2, 3, then of course it will need to now increase the size of the diagonal as well, right? And to increase the size of the diagonal, it will need to increase the number of rows and columns to 4.
Right.
If you do a if you do a 2, then it will need to increase the size of the matrix again, right? You can also do a -2. So if you do that, then see what is happening. It is actually populating this one, right? So it has very specific application areas, not something that I see you using ever. I have never used it so far, because all of these are only required when you are doing matrix operations using NumPy. But since most of us are, in the data analytics space, primarily, we do not necessarily need to use them directly. And we really do not know some of the functions that we may be using, maybe indirectly using these functions. But we really do not need to worry about them. In terms of using them directly, I do not really see that you may ever need to use these functions for the use cases that you work on. So moving on, random number generation, right? So we already looked at a range and we looked at linspace, right? We already looked at these, how we can actually generate these numbers and populate our array really quickly. There are other ways of doing the same thing, but then w- here the numbers are going to be random, right? So there are these examples, right, where you need to randomize stuff, right? So if you're generating a password, then you need to probably generate random passwords, right, using system time or any other factors, right, that you want to use. Uh, and there are these, simulations that you need to do where you will probably need random numbers. So give me a random number, or let's say you are, creating a game of, where somebody needs to throw a dice. Then you need to randomly generate what is the value of the dice throw going to be between 1 to 6. So how do you do all of these, right? For that, you'll need to come up with a random number, and the random number can be generated using the NumPy function called RAND. So how do you use this? np.random.rand, and then what you can actually specify is the number of rows and number of columns. And what this is going to give you is these many number of rows, these many number of columns. Let me keep it simple, 2 by 2. And how this is going to give you these numbers? These are going to be random numbers between 0 and 1. So if you look at this, this is a number between 0 and 1. This is also a number between 0 and 1. And that is why most of these numbers are between, uh, yeah, most of these numbers are starting from 0 dot something. And all of these numbers are going to be 0, between 0 and 1. And you have a choice. You can specify the number of dimensions. based on your need, right? So you can specify a 3 by 3 as well. You can specify anything for that matter.
So rand function by default automatically taking a range 0 to 1, right?
Yeah, yeah. It will always have a range between 0 to 1. This is not something that you can change here. But if you really want to change the range itself, then you can just multiply this with whatsoever number. So you'll need to do a mathematical operation to change this range if you really want to do that. And that is going to be very simple logical operation. If you want these to be changed to from 1 to 10, then you can simply do that by performing some logical operation on top of these array. That is possible. Okay. Same ways we have a rand n function, right? Now, what does it do differently than rand? So a rand will give you these numbers as random numbers, and a rand n will also give you these numbers as random numbers. But see, these numbers here are between 0 and 1, right? But then here, when you look at this, some of these numbers are negative as well. Now, what does it mean? And why is it doing so? So here in the definition, I have put in something, right? Numbers from normal distribution with zero mean and standard deviation of 1. So this is the extra thing, which is what this function is doing, random normalized. So what happens is, let's say if you want these numbers to be having a mean value of 0 and a standard deviation of 1, then you should use a rand normalized function. Otherwise, you can use a rand function. So if you calculate the mean of these numbers, you will get 0. And that is why what it is trying to do is, it is, see, some of these numbers are even greater than 1, and some of these numbers are negative as well. So if you calculate the mean of these numbers, you'll get 0. And the standard deviation, if you calculate the standard deviation of these numbers, you're going to get a 1. And that is what is, if any list of numbers, right, any set of numbers follow these two criteria, where the mean is 0 and standard deviation is 1, then we call that as the list is following the normal distribution or standard distribution. And if you need that kind of a list, then you can use the rand n function. So that is the only difference. Here, the numbers are not going to be confined between 0 and 1. You will have any set of values, because the 0 mean rule should be followed. The standard deviation value of 1 should be followed in this case. So if you plot these numbers, what you're going to get is a bell curve like this. You're going to get a absolute bell curve like this. Whereas when you, so this is what you're going to get in case of a rand n function. But in case of rand, the curve may be like this, it may be like this. Yeah, it is definitely not going to be something similar to this, because this curve means that the mean is equal to 0 and the STD, standard deviation, is equal to 1. But here, both of these are not true. These are not true. Here also this is not true, right? Okay. So rand and rand n, right? Uh, this is something that we can look at, and let's look at this really quickly. So Gajendra, I think you had this question. What if I do not need the decimal values, right? Again, there is
Yes.
another function called rand int that you can use. np.random.rand int. You can specify. Now, the good thing with rand int is you not only have control on the data type, but then you also have the control on the range. Now, when you look at these numbers, these are all within a range, right? And what is the range? The range is 1 to 100. And how many values we are fetching? We are fetching 4 into 4, 16 values in total. And that is what is happening. So let's say if you want to simulate this for um simulate this for set of dice throw, uh, right? Then you can actually do this using this. So if a dice is thrown 16 times, then randomly these are the values that you may get. If you run this again, you will get different values. Every time you run it, you are going to get different values. So if you look at this matrix, this is going to just keep changing every time you execute this, right? So did you notice one thing, that you're not getting a 6 value ever, right? And that is
Yeah.
and that is because
So
the
0 to 5, 15
yes.
changes.
So the last value is skipped, right? So for that matter, you will need to actually do a 1 to 7 so that it gives you values 1 to 6. Right? Okay, so rand int is something that I see you using more often than rand or rand n function, right? Because this is definitely more uh, widely used. Reshape. So reshape is something that we have already seen, and we can actually skip it here. We have already seen this right earlier. Reshape is used to change the row and columns, right? So we already seen this. You can do a 4 by 4, 2 by 8, 8 by 2, and stuff like that. So some more examples of reshape, and you can actually use reshape by specifying these two parameters. What is also available is, and we have already seen shape, right? What is available for you to use is max. So if you want to see out of these values which are randomly generated, what is the maximum value? So you can use dot max, you can use dot min, you can use uh, mode, you can use uh, dot mean, right? So max, min, mean for average, and mode for the most frequently occurring number. These are all the values that you can actually use. So so this is simple. We have already seen how to use reshaping, right? The function is very simple. You just use reshape. Okay, indexing and slicing, right? So one thing which we have seen with uh, not just the lists and tuples and dictionaries, how do we find out, or how do we fetch the specific values of these specific values from these positions, right? So in our this example, right, which we saw earlier, how do we fetch, let's say, all the elements starting from second position, or maybe specific examples like how do we fetch all the values starting from second position to fourth position, or maybe how do we fetch all the values starting from second position to the end position. How do we do all of these things, right? This is what is called slicing or indexing in Python, and we've already seen this earlier. It's going to be very easy for arrays as well. What we use is the index number, and it all starts with 0. So this is very simple. It is the same as how we have referenced lists as well. So what we are doing here, we are quickly creating an array, right? Starting from 0 to 10. So 11 elements. And this is the seventh element, right? If you need to print the seventh element, you just specify 7. And this is going to print you the seventh element. What you can also do is you can specify two elements, right? So you can specify 3 to 6, which means third, fourth, and fifth position elements at that location. So this is going to give you 3, 4, and 5. And we have already seen, right? If you skip the first parameter, then what you are specifying is starting from the left, right? So actually, this is going to give you starting from left first four values 0, 1, 2, 3. And if you want to go backwards, then that is also a possibility. It will start from the very right position, and then this is going to move till the seventh, and then the step size is going to be -1, which means that we are moving in the backward direction, taking one step at a time. So all of these things we have already seen with list and tuples, and that is exactly how it will work here as well. So there's nothing new in here. I've already all explained these concepts to you guys, and I hope you are able to recall these as well. The idea is very simple. All of these items are indexed and they have a number 0, 1, 2, 3, 4, 5, 6 till the end. And you can, for any number, just use the index number. For any position, you can use the index number for that position and then refer to that element. If you want to fetch multiple values starting from one position to any another position, then you can just specify them separated by a colon, and that is how it works. So nothing new for me to teach you here. This is something that we have already covered, and this is exactly how you should be doing this, the way we have done this for list. Let's move on to figure out what is subsetting, right? So subsetting is a concept where you derive a matrix out of another matrix, right? And how do we do that? So let's say this is the matrix, right? This is the matrix that we have created. The elements are from 10 to 100, right? And the step size at max is going to be 15, right? So this is a random list, or this is a random matrix, you can say. What we can do is we can create another matrix out of this matrix where where this condition is true, where the value of the matrix is more than 50. So what we are trying to do, we are trying to subset, right? Or we are trying to create a subset from this set. So this is my superset of matrix, and we are going to create another subset which is a mini set or a mini list out of this matrix. But the condition is very simple, it should satisfy this condition. So all the elements which are greater than 50 will become part of the subset, and this is what is going to happen here, right? Let's execute this. So we are getting this as a list, right? And when we do the subsetting, then all the elements which are greater than 50, right? 88 is part of the subset, right? 54 is part of the subset. 32 is not part of the subset. Now 74 is part of the subset. And again, if you look at 17, this is not here. So what is subsetting? Subsetting is when you create a small set out of a bigger set. And how do you do that? For creating a small set from a bigger set, you definitely need to have a condition, right? Or a criteria. And you can think of this as a where clause, right? Where the value is greater than 50. And you can change this, right? You can change this to anything where the value is less than 50. So you can create that list as well, right? So it is very simple. Subsetting at first may look like this is a pretty complex topic, but then subsetting is very easy. And we have done this in Python pandas as well, right? Where you can actually filter out elements using any condition. And there we were using the name of the column. Here we will use the name of the matrix itself, right? Because there are no different column names, right? There is just one variable name, so we can just specify this. And what if, let's say, we specify mat is equal to 0. So did we have a 50 here? Yes, we had a 50 here. And that is why we have just one element in here. But let's see. Now we do not have any 50 here, right? And this is going to be an empty list. So I'm just going to change this to greater than so that you always have values populated in here, and you can actually look at it that ways. So
Manish, one question.
yeah.
Like if we get some random elements here,
Hmm.
right? So we don't know how many elements we are getting over there, and we want to convert it into the multi-dimensional array. We want to reshape it. So
Right.
can somehow we can pass some logical thing like the count of element divided by
Yeah, we can
two.
do that. So this is a what is this giving you? This is giving you a list, and you know how to count the elements of the list, right? So the moment you are able to count the elements of the list, then you only need to do two things, right? You need to at least have one thing already defined, right? Which is the number of rows or columns. Then you can calculate the other element, right? If you have, let's say, 15 elements here, and you have already defined number of rows as 3, then your calculation will result columns as 5. The only problem is that You really do not know at any given point in time how many numbers you will have here. So by
Right.
chance you have nine numbers here, right? But when you run it the next time, now you have only six numbers. So what do?
Right.
Right? You cannot fix the number of rows and columns forever. It will need to be recalculated. Two, four,
Yeah. So
six,
based
eight,
on
ten.
the count of elements, we can define the row and column, right?
Yes, so what you can do is you can just count the number of elements. If it is turning out to be uh, an odd number, then you'll need to treat it differently. If it is turning out to be a even number, then you'll need to treat it differently.
Right.
But then you can do that. It'll need to be built logically. There is nothing available in Python that lets you do that directly. So, okay. Now let's look at slicing a bit, right? And slicing, what we are doing now is we are slicing things a little differently, right? What you can do is, and let me give you a example here so that you can understand it a little better. Now, this is also something which is not very widely used, but then you should know these concepts as well. Let's say you have these elements. And you have already seen that we were able to find out all the or take out all the diagonal values, right? The top left to bottom right. What if we want to carve out this one? Can we do that? Yes, that is possible. Is there a possibility that I can take out this and create another matrix out of it? Yes, that is possible. Is there a way where we can maybe use or carve out this much, these many rows and these many columns, and create a matrix out of it? Yet, yes, that is possible. Can I take out these values and create a matrix out of it? Yes, you can do that. And this is what is also referred to as slicing, right? And that is what we are going to do now. The slicing that we did earlier, right here, right, was on a 1D array, right? It was on a 1D array. The example that we are going to see here is how do we do a slicing on multi-dimension array, and that is what we are going to see here. So see, we have a two-dimension array here where the number of rows are two and then the number of columns are two. See what we are trying to do here. Now mat slice is equal to this is the name of the variable mat, and then we are specifying colon 2 and colon 2. Now what is this doing? Try and look at yourself, right? We have not specified anything as the first element, so this will be the same as 0 0 2 0 2. So what is happening here? If you look at it, these two elements and these two elements are getting sliced out, which means this is my 0 and 1 number of row, 0th row and first row, right? So 0th row and first row. And from these two rows, the first two rows, I'm trying to fetch the 0th column and then the first column. So this column and this column. And this is what is going to be sliced out: 11, 12, 21, and 22. What if I change this to 0, 3? See, now there is something weird happening, and I'm not able to figure out why. No, this is fine now. So it was a variable confusion. Yeah, so now this is correct. See, I've changed the columns to 0, 1, and 2 now. So now it is picking all the three values from both of these rows. I can only do 0, 2, 0, 2, and this is how it is going to change. So these are all this way what you are able to do is carve out values or slice out values from another matrix and create a separate matrix out of it. And the same ways, I mean, all of these are possibilities. You can do anything. You can take out, let's take out these. Let's take out these four, the ones from the right, right? What will be the values that we will need to do? We will need to do 1 and 3, and then we will need to do 1 and 3. So what is happening here? It is actually taking out these values: 22, 23, 32 and 33. So basically, the only difference here is that instead of providing just the rows, we have to provide the column values as well, column index values as well. And if you do that, then it is actually going to give you the sliced matrix. And that is the only application of this.